there is a very important formula that we must consider. It's called Snell's law. So if you recall, I said previously, this is our core, this is our cladding. And here we have N1, here we have N2. Snell's law is very essential because it actually helps us to relate these different parameters, the refractive indices, the incident angle, the refracted, and the angle that is now going to form total internal reflection, and so on and so forth. Snell's law, this is very important. Snell's law. It says N1 sine theta 1 is equal to N2 sine theta 2. N1 is the refractive index of the core. Let me do something here. This is our normal. Actually, normal is supposed to be shown a bit differently. If this is our normal, it cannot be continuous. A normal cannot be continuous. So this is our normal. This, and this. This is our normal. This is our incident ray towards the normal. So we can call this theta 1. For the case of refraction, this is the angle. Call this theta 2. This is N1. This is N2. So N1 sine theta 1 is equal to N2 sine theta 2. So if you take the product of sine of the incident angle multiplied by its refractive index is equal to, if we take the product of refractive index of the cladding or second medium times the sine of its refracted angle. This is very important. And so, remember I talked something about critical angle. And I said critical angle is the angle of incidence for which the angle of refraction is equal to 90 degrees. So theta 1 for which theta 2, as you can see here, is equal to 90 degrees. What happens if we apply this into this formula? So we'll have N1 sine theta 1 is equal to N2 sine 90. What is sine of 90? Sine of 90 is 1. Therefore, we'll have N1 sine theta 1 is equal to N2 times sine of 90 is 1. So, we can say sine theta 1 is equal to N2 divided by N1. So, theta 1 is equal to sine inverse of N2 divided by N1. If we want to know the critical angle for a particular interface, if we want to know the critical angle for transmission in a particular interface of core and cladding, we must know the refractive index of cladding, must know refractive index of the core, and if we utilize the sine inverse of that ratio, we can be able to get the critical angle. So theta 1 here is actually our critical angle. Our theta 1 here is critical angle. And so if we calculate this, if we have refractive index of core and cladding, we can be able to resolve and see or obtain the critical angle. The angle for which, if light is shined onto the interface, it will actually emerge at the interface itself. If it is shined at a certain angle from the interface, it will actually emerge at the interface between these two mediums. This is a very important formula that can help us. So for different materials, for different interfaces, the critical angle will be different. And we know to get total internal reflection, we must make sure that our incident angle is above the critical angle that we see or that we have. Then we can achieve total internal reflection. This is very important. Thank you for listening.